Welcome to Question of the Week. This is the Facebook Live session where I take on your science faith questions. Every Monday, 9:30 a.m. Pacific Standard Time, 12:30 in the afternoon for those of you on the East Coast. This week's question comes from Ozan Cart, who asks, does natural selection really have the power to imitate a designer? This is a really good question. And in fact, I've been involved in a number of projects the last few weeks in which this question is coming up over and over and over again. Can natural selection imitate the work of an intelligent designer? In fact, this question is central to the creation-evolution controversy for those of us who are interested in that particular debate. And so I'm going to take on Ozan's question in just a minute. But before I do that, I want to remind you that if you are watching this broadcast either on Facebook or on YouTube, please take a moment in the comment section to identify yourself, say hi, let us know where you're watching from. This is valuable information for us to have. And in fact, the last broadcast that we originated, which was June 12, 2017, a number of you took the time to say hi. Roger J., who is a member of the Reasons to Believe chapter in Houston, Texas. Thanks for your involvement, Roger, in our chapter there. David John Finnemore from Sanford, Florida. Jim Seward, Central New York. Jim Runyon from the Chicago chapter of Reasons to Believe. And in fact, I got to see Jim just a few days ago when I was in Chicago taking part in the DeBar Conference, which was held at Trinity Evangelical Divinity School. This is part of the Creation Project, a 3-year program designed to elaborate the doctrine of creation. After that conference, our Chicago chapter hosted us informally for a barbecue, a meet and greet, and I got to see, again, my old friend, Jim Runyon. It was great to see you, Jim. Thanks for stopping by. Alexander Young also checked in. And then on YouTube, we had Christopher Bickle from Sacramento, California, John Packard from Seattle, Washington, James Raj from India, and Neil English from Scotland. So we're acquiring an international audience, but thanks so much for all of you for taking time to check in and say hi. Also, if you're watching this broadcast, interact with it. Hit the like button or post in the comments ways in which you think this broadcast could be improved. That feedback is much appreciated. And then finally, if you want to offer your perspective on this question, can natural selection imitate an intelligent designer? Please feel free to do so, even if your perspective disagrees with mine. I want to create environments on my public figure and my personal Facebook page where people can talk about important science faith issues without being censored, as long as those interactions are civil. Also, for those of you who are watching this on YouTube, please feel free to offer your counter perspective if you have one. What you say is really important to me. And again, the last time we did a broadcast, both Alexander Young and David John Finnemore offered some critical perspectives on my thoughts on the question, what do I do as an old earth creationist with the discovery of 300,000-year-old fossils of Homo sapiens? So anyway, thanks again for all of you who are watching this broadcast. Thanks for all of you who take the time to interact with the content of this material. Your thoughts are valuable to me and much appreciated. Okay, without any further ado, let's go ahead and take a look at the question on the table today. Again, can natural selection imitate an intelligent designer? Now, this, of course, is a really, really important question if you're interested in the creation-evolution controversy. And the first time this idea really comes to the forefront is in Darwin's book, Origins of Species. Darwin, when he wrote Origins of Species in 1856, was in part not only trying to address mechanistically how species might originate, which in his day was called the mystery of mysteries, but he was also offering a rebuttal to William Paley's book, natural theology. In this book, William Paley advances an argument called the watchmaker argument for God's existence, where he argues that a watch and biological organisms have much in common. A watch is made up of pieces that interact in a precise way, that are put together to accomplish a purpose. And when he looked at biological systems, he argued they have those same qualities. Therefore, there must be a divine watchmaker that brought life into existence. And Paley's thinking influenced biology for 50 years, where biology was done as a teleological enterprise, where God's role in the design of life was clearly seen and studied. In fact, there was a debate taking place. Was function the most important quality to consider when trying to make sense of biological designs, or should we be looking at form, at archetypical templates? And in fact, Sir Richard Owen was looking to develop a model where both perspectives would be unified in a singular, grand unifying theory for biology. And along comes Darwin as he's working on this question about the origin of species, where he argues that natural selection and then later sexual selection actually shape species, and that is, species are not fixed, but they are plastic, and that this process of natural selection over time can generate new species from pre-existing species. So Darwin presumably solved, again in his day, the mystery of mysteries: where do species come from? But Darwin goes beyond just simply offering an explanation for the origin of species. He argues that this mechanism, if extrapolated over vast periods of time, could actually explain the origin of biological major groups. It could explain biodiversity throughout Earth's history, the biogeographical distribution that we see for organisms not only alive on Earth today, but throughout Earth's history. In fact, he argued that these mechanisms could explain adaptation and ultimately design. And what he did is he moved biology from a regime of teleology to a regime of mechanism. He mechanized biology, and in doing so argued that natural selection can imitate the designer. In Paley's book, Natural Theology, there is a chapter where Paley begins, and I'm paraphrasing, by basically saying that if we had no other example other than the vertebrate eye, we would have to conclude that there was a creator that brought life into existence, because the vertebrate eye is so exquisitely designed. And in response to that, Darwin writes these famous words that I want to read to you, which essentially argues that natural selection can imitate the designer. He says this: "To suppose that the eye, with all its inimitable contrivances for adjusting the focus to different distances, for admitting different amounts of light, and for the correction of spherical and chromatic aberration, could have been formed by natural selection, seems, I freely confess, absurd in the highest possible degree. If numerous gradations from a perfect and complex eye to one very imperfect and simple, each grade being useful to its possessor, can be shown to exist, if further the eye does vary ever so slightly, and the variations be inherited, which is certainly the case, and if any variation or modification in the organ be ever useful to an animal under changing conditions of life, then the difficulty of believing that a perfect and complex eye could be formed by natural selection, though insuperable by our imagination, can hardly be considered real." And of course, we have people like Richard Dawkins, who picks up this idea in his book, The Blind Watchmaker, where he argues that Paley had the proper reverence for the complexity of the living world, and he saw that it demands a very special type of explanation. The only thing he got wrong was the explanation itself. The true explanation had to wait for Darwin. Natural selection, the blind, unconscious, automatic process, which we now know is the explanation for the existence and apparently purposeful form of all life, has no purpose in mind. It has no mind and no mind's eye. It does not plan for the future. It has no vision, no foresight, no sight at all. If it can be said to play the role of a watchmaker in nature, it is the blind watchmaker. And this, in effect, is where this claim comes from, that namely natural selection can imitate the designer. Now, of course, Christian apologists who are uncomfortable with the implications of the evolutionary paradigm have challenged the blind watchmaker assertion. And a common way in which people go about issuing this challenge is looking at evolution's mechanism. Can evolution's mechanism really produce the complexity and the designs that we see in biology? And of course, the approach here again is to try to argue that if we really are critically thinking about the nature of natural selection and sexual selection, that there's no way that these mechanisms can produce the types of transformations needed to explain the design of life in the time frame that is available to it. This is essentially what we would do to examine any mechanism that is proposed to account for a change in the natural realm, whether it's in the biological realm or otherwise. So it's not an unreasonable point of attack against the blind watchmaker challenge. The problem is that this approach currently is doomed to fail. And the reason why I say that is because we don't have fundamental understanding about key aspects in biology that are necessary to effectively evaluate the efficiency and the efficacy of this particular mechanism. For example, we don't know at a biochemical level the relationship between amino acid sequence and protein structure and function. And unless we have that understanding, we simply can't say one way or the other whether or not natural selection has the capacity to, again, produce the design and the complexity that we see in biochemical systems. We don't understand the relationship between the genetic makeup of an organism and its phenotype. We don't understand the relationship between genotype and phenotype. How does the information in the genome translate into physical and behavioral properties that an organism would possess? We don't know the answer to that question whatsoever. And so until we know that answer, we can't really argue one way or the other about the efficacy of evolutionary mechanisms to account for the way life looks. In other words, when Christian apologists try to undermine the claim that evolutionary mechanisms are sufficient to explain the origin and the design of life, we're making a God of the gaps argument. We're proceeding from genuine ignorance because nobody knows these relationships. But on the other hand, evolutionary biologists that are making the claim that evolution can account for the origin and the design of life, too, are arguing in a gap-like manner. It would be evolution of the gaps. Without that understanding, we cannot do a good mechanistic characterization. Unfortunately, many of the most common arguments that people advance for biochemical design, let's say, fall into this category where they're trying to challenge the mechanism. One of them is a very common argument from irreducible complexity. I have grown somewhat sour on this argument over the years. And as I say that, I first of all want to make sure that people understand how much respect that I have for Michael Behe, who is the person who really established this argument and advocated for it in his book, Darwin's Black Box. In this book, Behe argues that biochemical systems are irreducibly complex, and he maintains that those types of systems cannot be produced through evolutionary mechanisms, through evolutionary processes driven by natural selection. Again, I have enormous amount of respect for Behe as a scholar, as a thinker. I deeply admire his courage, but unfortunately I just don't think this is a sound argument for a number of reasons. Because Behe's point would be this, that these kind of systems that are irreducibly complex have no function unless all the parts of that system are present and are interacting precisely. In other words, you can't put that system together in a stepwise manner where there are intermediate stages to that system, because those intermediate stages would not have function. There's nothing for natural selection to choose. Therefore, those systems have to come together all at once. That is, they must be ultimately designed. Now, the problem with that argument, though, is that evolutionary biologists have suggested a mechanism for this called co-option, where they argue that you could have intermediate systems leading up to a final biological or biochemical system, where those intermediate systems would have function that would be distinct from the final function of the system, of the ultimate system. And that evolution would co-opt existing designs and cobble them together to produce new designs, or those new designs are made up of components that carried out different roles in the cell or in the organism prior to, again, that evolutionary transformation through co-option. Now, we can spend all day and all night arguing whether or not co-option is a valid mechanism. It clearly is part of the construct of evolutionary biology, and it was part of the construct prior to Behe proposing his argument for irreducible complexity in his book, Darwin's Black Box. But the fact of the matter is we can't really fully adjudicate that argument until we have better understanding about the origin of body plans and the origin of protein systems. And again, key relationships like the relationship between genotype and phenotype and amino acid and protein structure. What I've been doing recently is exploring other ways to challenge the watchmaker argument that don't get us mired in this no-win, no-lose situation, this God of the gaps reasoning, or this evolution of the gaps reasoning. And that is to turn to work that's happening in two areas of technology. One of them is synthetic biology, where the goal in synthetic biology is for scientists to create novel, unnatural organisms. And there are two ways scientists are going about doing this. One is called the top-down approach, where scientists are trying to re-engineer organisms to produce organisms that are unlike anything found in nature. For example, you could take the bacteria E. coli and engineer it to produce certain drug compounds that would have utility, let's say, in combating cancer, where you're literally re-engineering the metabolic capabilities of a bacterium like E. coli, producing an organism that would produce, again, drug materials. This would be the top-down approach to creating new organisms. The bottom-up approach would be starting with simple chemical materials and trying to create protocellular entities that assume the properties of life, and maybe one day even getting these protocellular entities to interact with each other to form multicellular complexes. Whether you're looking at the bottom up or the top down approach, in both cases, these studies clearly indicate that to bring about new life forms, whether from chemical materials or from pre-existing life forms where they would evolve, quote unquote, in the lab through a creator or through a researcher's involvement, both approaches indicate that intelligent agency is absolutely dispensable. Both approaches indicate that whether you're transforming an existing organism or trying to create a cell from scratch, that you have to develop elaborate, sophisticated strategies that are predicated on decades and decades and decades of research and understanding about how biological systems work. These strategies then have to be translated into sophisticated protocols that are carried out by highly skilled, highly knowledgeable scientists under exquisitely controlled conditions in a laboratory setting. In other words, empirically, time and time again, we've shown that whenever you make overtures to try to create new organisms from existing organisms or from chemical systems, you have to have intelligent agency as indispensable. That is, the watchmaker has to be fully sighted. And this, to me, is a devastating blow to the watchmaker, or to the blind watchmaker challenge, and provides very powerful support to the classical and a revitalized watchmaker argument. Because we're showing empirically what it takes to transform life or to create a new cell from, again, chemical materials. Intelligent agency is absolutely indispensable. The watchmaker has to be able to see and anticipate what is going to happen to pull this off. The watchmaker is not blind. And this is, again, a way around the deadlock that surrounds the current debate about evolution's capacity. Another intriguing area of research and technology development that, again, I think weighs in on the blind watchmaker challenge has to do with two areas that are interrelated to each other, called bioinspiration and biomimetics, where scientists are turning to designs in biology to inspire new designs, whether in nanotechnology or with respect to more macroscopic systems, or they are simply just copying those designs and implementing those copied designs into nano devices or to macroscopic devices. This is a very exciting, innovative area of engineering today and technology development that, number one, highlights just how elegant biological and biochemical designs are, and in and of itself is highly suggestive that there's a mind behind life itself. But this also raises questions about the blind watchmaker mechanism, because evolutionary biologists argue that evolution does not produce perfection. It produces systems that have been cobbled together through an unguided, historically contingent evolutionary process that's co-opting existing designs, modifying them, and cobbling them together to make new designs that then natural selection can fine-tune and perhaps optimize, but inherently these designs are of limited perfection. And this is not something that, number one, I would expect scientists and engineers to turn to as designs to inspire engineering. This would be the last place that someone would want to look. But it also represents, I think, a very serious response that to the co-option argument, to the co-option challenge. Because if co-option is the mechanism, then we would expect biology and biochemistry to look a certain way, to look, again, as if it was poorly designed. In fact, Ken Miller wrote one time, evolution does not produce perfection. The fact that every intermediate stage in the development of an organ must confer selective advantage means that the simplest and most elegant design for an organ cannot always be produced by evolution. In fact, the hallmark of evolution is the modification of pre-existing structures. An evolved organism, in short, should show the telltale signs of this modification. But I would argue that thanks to biomimetics and bioinspiration, the answer to that question, or to the response to that, is that they don't show these telltale signs of that type of modification. Again, biomimetics and bioinspiration fit naturally and comfortably in a design framework, but fit awkwardly in an evolutionary framework. It's not what we would expect biology to look like. It's not what we would expect biology to be capable of, that is inspiring new technologies. And so the point I'm making here is that thanks to advances in synthetic biology, in biomimetics and bioinspiration, we have responses to the watchmaker challenge, to the blind watchmaker challenge, and those responses are empirically generated. They're not arguments that are theoretical in nature, bickering back and forth from a basis of incomplete knowledge what evolution can or can't do. This is essentially empirical evidence that the watchmaker cannot be blind, that the watchmaker has to be fully sighted. And so it also, I think, represents a powerful piece of evidence that buttresses Michael Behe's irreducible complexity argument. Because even though co-option is now part of the construct of evolutionary biology and is the way people are trying to sidestep that, I think the work in biomimetics and bioinspiration actually provide us with a response to this co-option challenge to Behe's argument, and with that give new life to the case for irreducible complexity. So anyway, I'm going to go ahead and bring things to a close. Thank you so much for watching this broadcast. I hope it's been helpful to you. Thank you for your questions. If you want to ask a question for consideration in an upcoming episode of Question of the Week, please post it on my Facebook page, whether my personal page or my public page, my public figure page. You can private message me. You can pose the question to me on Twitter, or you can pose the question on the comment section on the YouTube broadcast of Question of the Week. Also, again, I just want to remind you to take the time, if you're watching this, to check in, to say hi, let us know where you're watching from. Please like the broadcast or offer your suggestion on how the broadcast can be improved. All of this activity elevates the profile of this broadcast in the Facebook feeds that people receive. It gives us a chance to more broadly disseminate this broadcast. And then finally, if you want to offer your thoughts on my comments on this question, please feel free to do so in the comment section. I'm going to close with one final thought, and that is this. The more that we know about science, the more that we have reasons to believe. Thank you. God bless you. See you next.